Hello guys, good evening and welcome back to 360DigiTMG's domain analytics program. It is the 8th day and it is the last day of the domain analytics. From the very beginning, I'll quickly go through what are the things that we have discussed and what we will be discussing in today's class and what is the agenda for it. And we'll discuss that and then we'll get into the session. The very first day, it is domain analytics of web and mobile. So with in the very first day that we have discussed what are the applications of machine learning when it comes to web and mobile. So where exactly we can apply the machine learning model that we have seen. We have gone through different cases because of using the machine learning. The profit margin or the sales ratio has been increased. We have seen those few examples, and and we've seen where exactly we can apply the machine learning model and we can improve the sales of particular product that we have seen. And then we have gone through the CRISP-ML methodologies. CRISP-ML. If you haven't watched those videos, please go through those videos. It will be on the name of web and mobile analytics. In CRISP-ML methodology, what are the phases we'll be having when it comes to data science project, irrespective of the domain, cross-industry, irrespective of any domain, we'll be using the same phases, 6 phases that we have seen. What are the phases we'll be having? What happens in that each phases? We have seen the hierarchy that is on the very second day, and then we have seen what are the different algorithms we'll be having. Machine learning primer, the supervised learning we have seen. What is supervised learning? And unsupervised learning we have seen. Unsupervised that we have seen. In that unsupervised, what happens? What is the process? How we are splitting the data when it comes to supervised learning, and how we are testing all those processes we have seen when it comes to machine learning primer. And then we have gone to pre-processing, exploratory data analysis. Exploratory data analysis and pre-processing. Pre-processing is kind of cleaning the data. When you have received the raw data from different sources, in that case, there might be anomalies in your data, like missing values, duplicate values, all those things. And we have seen how can we tackle or how can we clean those data? How can we avoid those anomalies, whatever the anomalies that are present in our data? How can we avoid that? How can we clean that? That we have seen. When it comes to structured data, we have seen what are the different techniques we'll be using to clean the structured data, and also we have seen unstructured data. How can we clean the unstructured data? That also we have seen. Structured data and unstructured data, you might be having an idea. When the data is in the form of tabular, rows and columns, in that case, we will be calling it as structured data. And if we are not able to put those data into the tables, in that case, we will be calling it as unstructured data. And that textual is also one of the unstructured data. So we have seen how can we clean the unstructured data. When it comes to structured and unstructured, the pre-processing are different, completely different. So we have gone through that. What are the different pre-processing techniques we'll be having, and how can we clean data? That we have seen. And the next day that we have taken one unsupervised learning. Unsupervised learning, machine learning algorithm, that is K-means. We have taken K-means algorithm, then we have seen how K-means algorithm is working. What is the mathematics behind that K-means algorithm that we have seen. And then we have taken one use case scenario to K-means, and how can we apply the K-means when it comes to real time. That also we have seen. And the next day that we have taken one supervised algorithm. We have taken the supervised algorithm, that is KNN. We have gone through the KNN algorithm. How does it do the prediction, based on which it will do the prediction? What are the metrics we'll be using, to categorize into different classes? And we have taken one more use case scenario when it comes to KNN algorithm, and then we have applied in real time to see how can we do the classification. And then we have taken one decision tree algorithm. Same in supervised. What are the algorithms that we have discussed till now? One is KNN, K nearest neighbor, and then we have taken decision tree, and then we have seen linear regression. In decision tree, we have taken one use case scenario, and how can we do classification using the decision tree that we have seen. And then we have taken linear. These are all comes under supervised. These all algorithms are comes under machine learning algorithm that we have seen. How can we implement decision tree? And we have taken one use case scenario, and then we have done the prediction as well. And the last session, we have taken the linear regression. In that linear regression, we have two types. One is simple linear regression. We have multiple linear regression when it comes to regression cases. And then we have a logistic regression as well, but we'll be using that for classification. So we have discussed two cases, that is simple linear regression and multiple linear regression. What are the different difference between simple linear regression and multiple linear regression that we have seen? And then we have taken one use case scenario, that is price of the mobile prediction. Mobile price prediction. Based on what? Feature. We'll be having different features. Battery, how much is the battery? Milliampere, and then we have seen what are the different specific cases. What is the RAM? What is the ROM? All those, based on those, we have tried to predict the price of that mobile that we have seen. In this session, we'll be taking neural networks. We'll be taking one neural network that is multi-layer perceptron. It is a very basic one, very basic algorithm that is also called as an artificial neural network, ANN. It is also called as an artificial neural network. We'll be taking this, and we'll see how artificial neural network perform. We'll be taking one use case scenario, and we'll try to apply in real time. So when it comes to artificial neural network, whenever we are talking about the artificial neural network, you might be having an idea. It is part of machine learning only. So most of the people have a confusion when it comes to different terms: AI, data science, machine learning, and deep learning. So deep learning is part of machine learning only. Machine learning, deep learning, and some mathematical operations or mathematical statistics, you can call, mixture up. Using all those things, we'll be doing some prediction. That, we'll be using that in data science. Whatever the application that we are creating, using all those things, we'll be calling it as the end user product. End user product, will be calling it as AI, artificial intelligence. So, like I mentioned, ANN, artificial neural network, or you can also call, it is part of a deep learning. Deep learning. This deep learning is subset of machine learning. It is a subset of machine learning. Yeah. So when it comes to agenda of this session, neural networks when it comes to web and mobile analytics. Neural networks when it comes to web and mobile analytics. What is a neural network primer? Perceptron, what is a perceptron? What is a multi-layer perceptron that we will see? And what are the activation functions? What is the error surface? And what is the gradient-based, gradient descent algorithm? These are the agenda when it comes to today's class. We'll be going through each and everything, and we'll try to learn a few things. In neural network primer, what exactly neural network? How the process will be done, and what is the perceptron? When you have a just single input output, in that case will be if it is linear, not single. If it is linear, in that case we'll be going with perceptron. And if you have some non-linear and you want to do the prediction, in that case we'll be going with multi-layer perceptron. And what are the activation function? Where exactly we'll be using the activation function, that we will see. And the gradient descent algorithm. What is the gradient descent algorithm? Where exactly we'll be using it? That we will see. So whenever we are talking about the artificial neural network, so what we are trying to do is, we will be creating the mimic of human brain. How does human brain function? We are trying to copy that human brain functioning into the neural networks. Neural networks. So you can see there are dendroids. You can see there are different dendroids. When it comes to neural networks, we'll be calling it as inputs. And whatever the input that we are giving into this cell, it will be processing, and then it will be transforming or even giving output to. So here we'll be taking all these are the all input signal, and then it is processing, and then it will doing the transaction. The similar we'll be applying when it comes to neural network. You can see here, these are the inputs. There's different features that you are using, and these are the hidden layers. Whenever you are going with multi-layer perceptron, you can use hidden layers to process the data. You can use any number of hidden layers. It's up to you. I mean, it depends on the requirement also. And then we'll be having output. It is a artificial neural network, ANN. It is a mimic of human brain. It will be taking the inputs, and then it will be processing, and then it will be giving you out. The reaction is, see, just consider one example. Let's say you have touched some hard surface. How long will you be, keep touching that surface? Once it is too much, in that case, it will burst. I mean, the output, you won't, you won't be able to hold longer. In that case, you will move away from the hard surface. That we'll be calling it as action. So that what is the output that we are getting? It is a kind of action. So this is how the human neural networks work. I mean, human body works, and here we'll be mimicking the same thing when it comes to artificial neural network. So whatever the process that is happening inside the neural networks, it is completely, we don't have any idea about it. We won't know what exactly happening inside the neural network. That is why it is called as black box techniques. So whatever the things that are happening inside the neural networks, you won't be able to understand. That is why it will be calling it is called as black box techniques. You don't know what exactly it is happening inside the neural networks. So this is the neural network introduction. So what exactly the neural network? It is just a mimic of the human brain. Similar to the human brain, we will be having the inputs as well as processing units, and then we'll be having output. In neural networks, we'll be having different types. Neural networks is a machine learning model inspired by the networks of a biological neural found in our brains. So what is it? Neural networks. It is a mimic. I mean, like I discussed earlier, it is inspired by the network of biological neurons that is found in our brains. It is just a mimic of our brain neurons. So when it comes to types of deep neural networks, we'll be having ANN, that is also called as a multi-layer perceptron. And then we'll be having convolution neural networks, and then we have a recurrent neural network. One fun fact, a human brain is made up of 85 billion neurons. It's humongous. A human brain is made up of 85 billion neurons, resulting in a network capable of representing tremendous amount of knowledge. Whatever the knowledge that we are using, it is coming from this only. The all process of 85 billion neurons. For instance, a cat has roughly a billion neurons. Mouse has about 75 million neurons, and the cockroach has only about a million neurons. So based on, you can say the number of neurons are high. In that case, intelligence of that particular person is increasing. You can simply check that cat about billion, and mouse has about 75 million. Cockroach has only about a million. In contrast to many ANNs contain far fewer. So whenever we are creating the ANNs, contain far fewer neurons typically on several hundreds. We'll be having just hundreds of neurons only whenever we are creating. So we are in no danger of creating an artificial brain anytime. So we are not near to the actual art, mimicking, like we have discussed. ANN, I mean, neural network is a mimic of human brain. So we are not anywhere near to the creating the actual human brain, since whatever the neurons that you are using are in several hundreds only. Count up in hundreds only will be having the neurons. So yeah, that is one thing. These are the different deep neural networks will be having. So how does perceptron algorithm works? So perceptron algorithm is the two-class binary. See, whenever you have a binary classification, that means will be having just one output at a time in two classes. Binary class means you just have a two class, whether it is yes or no, whether it is approved or rejected, or positive or negative. Like that, just two cases we will be having. In that case, we will be calling it as binary classification, machine learning algorithm. Similar to the machine learning algorithms, also will be having binary classification. So the perceptron algorithm is a two-class, that is a binary classification learning algorithm. The building blocks of the neural networks are neurons. So when it comes to components of the neural networks, we'll be having neurons, weights, and activation function. These are the main building blocks or the components when it comes to neural network. It has a single node or a neuron that takes raw data as an input and predicts a class label. So it will simply take the inputs and it will do the prediction. Weights are weighted inputs, threshold values, activation function. So these are the changes that if you want to, if you have some errors in our data, based on what you will be correcting the error function, you will be using the weights. We will be changing the weights. Based on that, we will be correcting the errors. So this is achieved by the calculating weighted sum of the inputs. So how normally the perceptron will work, we'll see. Let's say Here are here you have a summation function. These are the inputs, the number of features you will be having. So normally a single layer perceptron will be looking like this. So here we'll be having summation and activation function. So here these are all inputs. These are all inputs we'll be having, and here we'll be having weights W1, W2, W3, W4. How these weights are assigned, we don't have an idea since it is a block box techniques. It depends based on the features. So what happens here, whenever you are giving an input, it will be multiplied with weight and then it will be supplied to the summation. Based on that, whether the activation should be activated or not, it will decide. If if it reach the threshold value, in that case, activation function will be active and then it will shoot the output. It will shoot the output. This is what happens when it comes to single layer perceptron. But whatever the output that we are getting, that if it is having some error, in that case, how it is do the rectification. So whatever the output that we are getting, it will come back to initial point and then weights are started adjusting. So when you have some errors, in that case, it will come back to, and then will weights start adjusting. Then again, we'll be getting output each time. If you go like that, and it will increase the accuracy of the model. So that will be calling as every time the output come back to the input. In that case, we'll be calling it as one iteration. It is called one iteration, and the process is called as a back propagation. The process is called as a back propagation. So what is the back propagation? Whenever you're having the error, whenever we are having the error, that error is again supplied to the input, and the weights are getting adjusted and the error will be decreased. This is called learning rate also. The learning rate. Whatever the error term that is coming back to the initial input, in that case we'll be calling it as learning rate as well. So back propagation, where exactly we'll be using to decrease the error rate of the neural network. So we'll be using back propagation to decrease the error will be adjusted by the weight optimization only. So all whatever the error, how can we adjust their error? Using the weight adjustment only, weight optimization only. Using the weight optimization only, will be decreasing the error of the neural network. It is when it comes to single perceptron algorithm. When you have just binary classification, then in that case we'll be using this. So you can see here what happens when you input. The input will be multiplied with weights, and always we'll be having bias in order to see when you have weights is equal to 0. In that case, it might collapse. The whole neural network will be collapsing. In that case, to avoid that, we'll be using the bias. We'll be using always. You will be having one bias. So this is the activation function. So whenever inputs, this is the input into bias and then weight. What are those? X1, it is the input, and into weight plus bias. This is the equation when it comes to input. If it is greater than some certain level, in that case, activation function will be activated and it will shoot the output. If it is not reaching the threshold level, 0 means it is some threshold level. If it is not reaching, in that case, the activation function would be activated. The output will be 0. So as the inputs are multiplied by model coefficient, as in case of linear regression or logistic regression, normalization or standardization of data prior to using this model will be most successful. See, when it comes to gradient-based algorithm, any gradient-based algorithm. So whatever the artificial neural network that we are using, it is also gradient-based algorithm. And the linear regression, all the regression-based algorithms, those are also based on the gradient-based algorithm. Gradient-based algorithm. Whenever you are using the gradient-based algorithm, you must do the normalization. Whenever we are using the gradient-based algorithm, we must do the normalization. Since whatever the inputs that we are using will be having high variance, whenever the input that we are using have a high variance in the data input itself. Let's say x1, x2, x3, x4. If x1 is equal to about the values are in the range of 0.2, 0.5, something like that, in between the range of 0 to 1 or some value, and x2 values are in the range of 100, and x2, x3 are the range of in the range of 500 or 1000. In that case, there is a huge difference when it comes to input variable itself. Huge difference in between input variables. In that case, we will be multiplying the with our weightage. So all the input feature will be multiplying with the weightage. In that case, it might be creating but bias output. It might be creating bias output. Why? So if you have, let's say you have 500 as input, and you are multiplying with the weight. The weight could be anything, depends. And here we have 0.04 only, and you are same multiplying with the weight. So the weights here that you are getting when you multiply the input with the weight, in that case you will be getting the high value. So in order to do the prediction, it might be having the high influence compared to the other features. To avoid that, we will be using the normalization. So what we will be doing in normalization, all the values, all the input values that we will be having, converting into in between 0 and 1. All the input values will be having, all the features will be converted into in between 0 and 1. 0 and 1 in between, so that we can avoid that biased output. So whatever the output that we are getting, if you have any error, in that case, it will come back to input, and then the weights are adjusted. This cycle, one cycle, it is called as an iteration. It is one cycle, it is called an iteration. The process is called as a back propagation. Back propagation. Let's say this is the one use case. So what happened here? The new weights. How does new weights have been assigned? So let's say this is the one use case scenario or one example. Let's say these are the different classes we'll be having. Whenever we are using the linear model, randomly one line will be created, and it will see whether it is classifying correctly or not. If it is classifying correctly, in that case, you don't need to do any changes. If it is not, in that case, so we need to adjust the weights. Whatever this is a new weights, and this is the previous weight, and it is the learning rate, and it will be the error, and it is the input. So this is the new weight, how new weight will be assigned or updated. So here it is a data points, and here we have misclassified. Whenever you have a misclassified, say it will be calculated error, actual and predicted. So what is actual? If you have 1 and instead of that it is predicted the 0, in that case that we will be taking as minus. So we will be taking this learning rate, optimum value we will be taking. Even if you take a high value or if you take low value, it will create a problem. How? We will see in a minute. So we will be carefully choosing that activation function, not activation function, it is learning rate. Optimum value we will be taking, and based on that we will be calculating the weights of new weights. Here you can see what are the new weights: 1 by 3, comma 5 by 6. These are the new weights, and these weights will be updated until and unless the process repeats until and unless all are classified correctly. Repeat until error is less than the threshold value. Repeat until less than the threshold value. Until and unless all the classification happened correctly, it will keep repeating. Here you can see again it is a misclassified case. So what happens? Again it will update the new weights. New weights, learning rate into what are the predicted case and what are the actual case into the else. Those are the input. Same again happened, and then update the weights. Now you can see it is a correctly classified case. So this is how artificial neural networks or multi-layer perceptron will work. It is a single layer perceptron. What are the things that we have discussed until now? Since it is a binary case, in activation function it will be having just one shoot and stay as it is. If it is greater than threshold value, in that case it will shoot. Otherwise, will stay as it is. So this is how we will be updating the new weights when it comes to single layer perceptron. So this is how actual architecture of single layer perceptron looks like. So here you can see all our inputs. These are, you can see here is x1, x2, up to. These are the feature. It depends on your requirement how many features you want. It is different features. Input vectors also you can build. These are the weights. How these weights are assigned, we have no idea. It is done by perceptron itself. Since that is why we'll be calling it as a block box technique. So it is a summation, and here we'll be having activation function. Since it is a binary case, we'll be using sigma. Since it is binary case, we'll be using this activation function. It will be having one case and two or 0 and 1. Just two output will be having. That is activation function. Threshold logic gate you can also call. So it is the integration function, or you can also call summation or aggregation. So whatever the inputs will be getting, it will simply calculate into x into w1 plus x2 into w2 plus x3 into w3. Something like that. Xn, Wn plus B. B is bias. So this is how the single layer perceptron will look like. These are the output. Even when it comes to multi-layer perceptron, you can use this. Anyway, you will be shooting just one. At a time, you will be getting just one output. So you can use that. So this is the single layer perceptron looks like. This is a function. Same that have created that equation, it will come from here. Sigma I is equal to 1 to. These are number of inputs. Weights into inputs plus B bias in order to avoid the collapse of the neural network. Yeah, whatever the thing that we have discussed now till now, that is a single layer perceptron. But what happens when you have multi-class classification? You need multiple output at a time. In that case, we'll be using the multi-layer perceptrons. It is a supplement or feed forward neural network. It consisting of 3 types of layers: input, output, and hidden layers. So we'll be having input, output, and the hidden layers. So this is how. So when it comes to multi-layer perceptron, it will be having connection with each and every hidden layer. It should be having connection with each and every layer. It is a mimic. That is why we'll be calling it. It will be having connection with each and every layer. This is hidden layer 1 and hidden layer 2. It is up to you. You can use any number of hidden layers, and it is an output layer. rate. And when it comes to learning rate, you have to choose optimum value when you use least learning rate. So these are, we'll see the learning rate what it is. It is an activation function. These are the different activation function we'll be having. Step activation function, we'll be having ramp activation function and sigma activation function. These are the different activation functions we'll be having. Sigma we'll be using when it is just binary classification. And you can use step function as well, but mostly we'll be going with sigma. Activation function decides whether the neuron should be activated or not. I mean, it should shoot the output or not. It will be decided by the activation functions only. By calculating the weighted sum, further adding the bias with it. So whenever we are calculating the weighted sum into x plus bias, after calculating this value, if it is reaching the threshold value, then only it will shoot the output. The purpose of the activation function to introduce non-linearity into output of the neuron. See, when non-linearity happens, whenever you have a non-linearity, that means when you have an equation, something like that, just two classes. There is one class that is red, and you have one more class. When you have something like that, in that case, you can simply use one linear line and you can do the classification. But when it comes to, when you have something like this, one and this one, in that case it is non-linear. How do you classify? In that case, we'll be using the activation function. Purpose of activation function to introduce non-linearity into the output of the neuron. Yeah, gradient descent algorithm. See, when you're talking about gradient algorithm, means we'll be reducing the error term. We'll be using gradient algorithm to reduce the error term. While you are reducing the error term, you need to choose that learning rate very carefully. Optimized value you have to check. If you choose the least value, in that case, let's say this is the gradient based gradient, and you are here, and you have a ball in your hand and you are simply throwing it very slowly. In that case, it is a, let's say it is a minimum. In order to reach this value, optimum value, you can say it is. In order to reach this, it will take time. But if you throw very fastly, in that case, it might be missing that that optimal value. Sorry, it might be missing the optimized value. So what we will do? We have to choose that learning rate very carefully, so that we won't be missing that, and it won't be taking maximum. It won't be taking much time. That we will be using the gradient descent algorithm. Gradient descent, in order to decrease the error term. Gradient descent is an iterative process. I mean, multiple iterations will be happening. First order optimization algorithm used to find local minimum of the given function in order to decrease the error. This method is commonly used in machine learning, that especially when it comes to regression cases, we'll be using a lot, and deep learning to minimize the cost or loss function in linear regression. Cost or loss function to decrease error term, that will be using the gradient descent algorithm. I will see the use case scenario. Will be predicting which category that particular mobile belongs to based on their inputs or features. Yeah, it is a algorithm. It is a use case, one of the use case when it comes to MLP. So what I'm doing here, based on the features, input features, or you can say mobile feature, you'll be having how much is your GB, how much your camera pixels, and what is the battery. Based on all those features, we have to decide which price range that particular mobile belongs to based on the inputs. What are those inputs? We'll see. So in order to, these are the different input features I'll be having. It is 4G or not, mobile depth, weight of the mobile, number of core processors will be having, camera megapixel, how much. So these are the different whether it is having 3G or not, whether it is having 4G or not, whether it is Wi-Fi enabled or not. These are the different features I'll be having. So data frankly, you might be having idea from 4 days we'll be discussing the same. So what we'll be doing with NumPy? We're simply doing the mathematical operations. Pandas, in order to do the manipulation, we'll be using Matplotlib to do the visualization. Cbon, we'll be doing using we'll be doing the advanced visualization using the Cbon. So these are the necessary libraries, and I'm importing all those things. Standard scalar, in order to do whenever we are applying the gradient-based algorithm, it is suggested to go with normalization or standardization, any one of those. And then I'm importing the MLP classifier. So I'm using other algorithm as well, just to check which one giving the best. So I'm using other algorithms as well. Here I'm importing the MLP, multi-layer perceptron, from where SQL on neural networks, import multi-layer perceptron classifier. Since the case is classifier, since we have different category phones, we have to simply predict which category it belongs to based on the input features. I'm simply loading the data. So these are the different features. Then I'm doing the shape, and then I'm checking what is the description. Shape is how much? 2000 are the entries, and 21 features will be having. I have 21 features. And the description, what are the range of values? What are the range of values? You can simply see minimum and maximum. Here 501, maximum how much? 1998. Here minimum is how much? You can see the range is very high. The difference is very high. In that case, we have to go with standard scalar. See, you can see here pixel height, it is 1960. Here we have just 2, and here we have 2000. So there is a huge difference when it comes to input features, maximum and minimum value. In order to avoid the biased output, we will be going with gradient. What? Normalization or standardization. I'm importing the test data. Test shape, it will be having the same. Whatever the data set I'll be having, I'm splitting into train as a 2000 data and test as 1000. So it is about 33% I have given to test. The same features. Info, we want to know what kind of data type it is holding, the data frame ID. So it is not necessary, whatever the not necessary features will be having, I'm simply dropping it anyway. So what are the integer or continuous data? What are the categorical data will be having, or ordinal data will be having? I'm just checking it. And then we are doing the data cleaning. What are the duplicates value? If you have any duplicates value, I'm simply dropping it. Check the unique values, how many unique values you will be having. And then exploratory data analysis to check, can we find any inferences from the data. Heat map, what is the correlation between all the features? The number of features will be having how many? 21. Among that, do we have any correlation? Good correlation that we are checking. We can't find any good correlation other than this 0.6. So it is acceptable range only. So we don't have any strong correlation between input features. But train and test pretty much safe. And then we are doing the visualization of histograms. You can see not many will be having any normal data. So whatever the model that I'm building is very basic model, and if you want to do, you can go with transformation as well. These are the all pre-processing techniques and the visualization. Price range of pie chart. So mostly we'll be having all similar. Price ranging similar. So these are the classes. So we can say that whatever the classes that we are using is the balanced data. 500, 500, 500. Zero class. These are the price range of different mobiles based on different classes. Zero class, one class, two class, three class. These are different classes. These are the output labeled column, right? So we have equal number of classes. So it is a balanced data set. You can simply go ahead with the model. So these are the different visualization. Whether blue bars, dual SIM, we have in dual SIM. How many phones we have with dual SIM, without dual SIM? Dual SIM, yes. Dual SIM, no. 4G, whether you have 4G or not. If you have 4G, in that case 104G. If we don't have, the mobiles don't have the 4G, in that case 3G. Touch screen, whether we have touch screen or just keypad. Whether we have Wi-Fi or not in that. So these are the different features. Same when it comes to test data. I'm simply splitting into train and test, and these are the visualization whether we have any our outlier or not in our data, and then we are checking the normal distribution of that particular features. So here, whatever the data frames that I'm taking, features which are the important features, that only I'm taking. Let's remove unwanted feature. I'm simply dropping it. Drop the list. These are all the features that are not required for me. So I'm simply dropping it and splitting the data into test, X-test, X-train, and Y-test and Y-train by importing what? From SQL and model selection, import train test. Yeah. And since the variation in between the inputs are very high in that case, I'm going with scalar. I'm using the standard scalar instead of normalization. So I'm doing the standard scalar and then I'm splitting, fit and transforming into X-train and X-test. Then I'm applying the model. What are the models I'll be applying? And these are the different models I'm applying to check which performing the better. K nearest neighbor. These are the classification cases. Even MLB classifier that I'm using how many iteration? 1000 iteration will be having. Iteration when we'll be calling if it is continuously doing changing the error rate. If you have any error rate, in that case error, it will come back to kind of back propagation rate, how many times it is coming back. So I'm giving 1000 maximum iteration and then I'm building model. So you can see how much we got. These are the different accuracies when it comes to model. Here using the KNN I got 91 and using the linear regression, logistic regression I have 0.95 and the decision tree it is 87, random forest it is 92, SVM 0.94 and MLB we have 95.8%. So among those all the models you can say that MLP multi-layer perceptron performing the better since we have the 96 almost 96% accuracy. So and yeah, this is about the multi-layer perceptron. You can separately also apply the multi-layer perceptron, but I just want to check which model is performing. So whenever you are going for the artificial neural network, it is a tendency. I mean, it has tendency most of the time. Artificial neural networks only performs better and the accuracy will be high. And then I've tried to do the parameter for other algorithms to check whether we can improve the accuracy of the model or not. So this is the multi-layer perceptron. How can we apply the multi-layer perceptron when it comes to real-time case. And the use case scenario is what? I have different features of mobile. Based on those features, I have to categorize into different categories. 0, 1, 2, 3. I have created 4 categories. We have to simply predict which category that predicted that feature or that input for that input is belong to, that entry is belong to, which category we can segregate into. These are the use case scenario of the multi-layer perceptron and how multi-layer perceptron works and what is the difference between single layer perceptron and multi-layer perceptron. Yeah, this is all about today, guys. And if you want to, before going winding up the session, I want to announce one more thing, that if you want to start or kickstart your data science career, you can start learning the Python very first. That is very important. Tame Python session that we are going. When tame Python sessions are going on, trained by trainer is Bharani sir. You can simply search in YouTube tame Python session by Bharani. Tame Python. You'll be getting YouTube channel. I think 11th day is going on. If you want to start your career in data science, please start watching those videos. And yeah, and if you want to see the other use cases when it comes to web and mobile analytics, we will be having playlist when it comes to in 360DG. You can watch all those videos there. And yeah, thank you for joining us. And yeah, have a nice day. And we'll see you with one more domain analytics program in next. Yeah, bye.